Welcome back, Pre-Calc. Hope y'all are well. Our objective today is going to be to recognize and apply arithmetic and geometric sequences. I've got the checklist on the screen. You know what to do from here. All right, so a little bit of review first. Remember that a sequence is defined recursively if you are given the first term or first terms and then given a formula for how to find the remaining terms based on the terms before it. So first pause on the screen. Go ahead and copy the recursion formula I have here, and then find the first 5 terms for me. When you've got it, go ahead and hit continue. So in this case, we are adding 3 to the previous term to get the next term, so we should have gotten 2, 5, 8, 11, and 14. Now, the not so great thing about recursive formulas is sometimes it's not real clear. Like if I wanted to find the 20th term, well, then I would need to know the 19th, right? If I want the 19th, I need to know the 18th, and so on and so forth. And what I would really prefer is just a general formula so that if I want to find the 20th term, I can just plug in 20 for n and find it without having to go all the way back, working backwards to the first term. So that's going to be our goal today, is to work with 2 specific kinds of sequences and see if we can get pretty comfortable writing their general formulas. So the first kind of sequence we're going to look at is called arithmetic. And arithmetic is when you add the same value each time to the previous term to get your next term, which you can think of it as subtracting as well, because you can always add a negative, okay? So arithmetic, add a, and we call that number that we add each time to be our common difference, and it's denoted by D. So what was our common difference in the previous example? It was 3, right? I kept adding 3 to the previous term to get my next term. So here I would say D equals 3. Force a pause on the screen. Go ahead and copy A, B, and C for example 2. Hit continue when you're ready to do these together. Okay, so it says for each of the following arithmetic sequences, and arithmetic means we're doing what? We're adding the same value each time to get to the next term. Identify the first term, which remember we denote as a sub 1, and the common difference, which remember we denote as D, and a recursive formula. So in other words, some formula that would give me the next term as long as I have the term before it. Okay, so for example 2, part A sub 1, my first term is 5. What am I adding each time? I'm adding 2 each time, so D is 2. And so if I have a sub 1, then my recursion formula, I could say like a sub n plus 1 would be the previous term, which would be what? A sub n plus, and I would just keep adding 2, right? I could have also written this as a sub n is the term before it, which would be a sub n minus 1 plus 2. Either way, and I didn't have to use n, I could have used k or whatever letter you want. But the point is that we've got the first term and then a way to find all the other terms based on the previous term. Okay, all right, let's try part B. So the first term is 2, so a sub 1 is 2. What am I adding each time? I'm subtracting 1, but I need to know what I'm adding, so I'm adding a negative 1, right? So a general formula, I'm going to do a sub n plus 1. I take the previous term, a sub n, and add negative 1, or subtract 1. I'm going to force a pause on the screen. You try part C. Hit continue when you're ready to check your answer. All right, so a sub 1 is 2. Your common difference is 1/16, because notice 1 can be written as 16 over 16, plus 1 more would be 17 over 16, plus 1 more would be 18 over 16, which would reduce to 9 over 8, and so on and so forth. So one way to write that recursion formula is a sub n plus 1 equals a sub n plus 1 over 16. Again, we could have done something like a sub k equals the term before it plus 1 over 16. So more than one way to get to target, right? All right, so in general, our arithmetic sequences in recursion formula format take this form. A sub n plus 1 equals the previous term. Oh dear. A sub n plus whatever the common difference is, right? So I'm forced to pause on the screen. Will you just go ahead and write that real quick for me? All right, so a sub 1 is just a sub 1. A sub 2 would be the previous term, which would be a sub 1 plus d, right? A sub 3 would be the previous term, a sub 2 plus d. However, I know what a sub 2 is. It was the first term plus d, right? So let's make that substitution, that this is going to be a sub 1 plus d, and then I still have plus another d. All right? So if I combine like terms, I have a sub 1 plus 2 d's, which makes sense, right? To get to my third term, I would start at my first and then add d twice, right? For a sub 4, I can take my third term, which we said was the first term plus 2d plus another d, right? So it would be my first term plus 3 times d. Again, if I want my fourth term, I start at my first, and I would need to add d 1, 2, 3 times to get to my fourth term, right? So can you generalize this? Let's say if I want to find my 20th term, I start with my first term, and how many times would I need to add d? 19 times, right? So here's what we're going to do. For a sub n, write this for me. For an arithmetic sequence, a sub n equals the first term, a sub 1, plus d, how many times? And minus 1 times, right? If I want to find the fourth term, I need to add d 3 times. If I want to find the third term, I need to add d 2 times. If I want to find the second term, I need to add d just 1 time. So I start with the first term, and then I see basically how many skips away do I want to go. So if I want to go to the 20th term, I'm 19 skips away, so I need to add d 19 times. And this is great because we just found a general formula for arithmetic sequences. So now I don't have to keep going backwards and backwards and backwards to get to, say, the 20th term. Now I can just apply my formula. First pause on the screen, can you go ahead and copy example 3 for me? All right, so it says find a formula for a sub n. If a sub 1 is 15 and d is 4, and that's them giving us a d value is our indicator that this is going to be that this is indeed an arithmetic sequence. Remember our formula from the previous screen right here, that if I want a general formula, I'm going to take the first term plus d and minus 1 times. And so I think we have everything we need already because we have the first term and we have d. So we're just going to plug straight into that formula. So a sub n is the first term, 15, plus n minus 1 times d, which is 4. We're just going to clean it up a little bit to combine like terms. So I've got 15, and then go ahead and distribute that 4. So I've got 4n minus 4. So final answer, 4n plus 11. So again, now if I want to find the 100th term, I just need to plug in 100 for n, and then I've got it. First pause on the screen, go ahead and write the second part of example 3 for me. All right, so for this one, I do have the first term, so that's good, but what else do I need for my general formula? I need d, the common difference, right, which I wasn't given here. But what I can do is just basically see, okay, how many skips away am I between the first term and the fifth term, and also just divide this difference by how many skips. Here's what I mean. So d is going to be your difference in your term, so go 16 minus negative 4 over your difference in which terms you're looking at. So 5 minus 1 should look very similar to slope, okay? So I span a distance from negative 4 to 16, that's a distance of 20, right? And then I've got 4 skips, so d, 20 divided by 4, will be 5, right? So my general formula looks like this. A sub n is the first term plus n minus 1 times d, which is 5. And again, just cleaning it up, I keep that negative 4, distributing the 5 gives me 5n minus 5. So final answer, 5n minus 9. All right, first pause on the screen. Go ahead and copy these sequences for me. All right, so our directions say try to figure out both the recursive and the general formula for each of the following sequences. So if I look here at this first sequence, 2, 4, 8, 16, 32, what am I doing each time? I'm multiplying by 2, right? So to find, we'll do it this way, to find a sub n, I'm going to take 2 times a sub n minus 1, the previous term, right? So can we come up with a general formula a sub n where I could just say plug in 3 and get 8? How about 2 to the n? Will that work? We don't want 2 times n because that would create the sequence 2, 4, 6, 8, 10, right? And we want powers of 2 here. So I think 2 to the n will work. How about this next one? So a sub n is, what are we multiplying by each time? 1/3 times the previous term, correct? And so a general formula here could be 1/3 all to the n, right? Here, a general formula, we are doing what each time? Multiplying by 10. However, if I just try doing 10 to the nth power, we have some problems, right? Because 10 to the first is 10. 10 squared is 100, and then 1,000. So I can see I'm off by this factor of 5, certainly, right? So let's try multiplying by 5 and doing it this way. Now my first term is going to be 5 times 10, which is 50. My second term will be 5 times 100, which is 500. So I'm on a good track, but I'm off by one term, right? So when we're off by one term, since we're kind of 1 too high, you want to subtract 1 to your exponent here. And now let's try. So now when I plug in 1, I would get 5 times 10, 1 minus 1 is 0. Anything to the 0 power is 1. So now my first term is 5, and I think we got it there, right? Second term is going to be 5 times 10 to the 1. That would be 5 times 10, which is 50. All right, I'm going to force pause on the screen. See if you can figure out that last one. Hit continue when you're ready to talk about it. All right, so hopefully we notice that we are multiplying by -1/2 each time, right? That's what creates this alternating sequence where the signs alternate each time from positive to negative, etc. So let's maybe take a cue from what we did up here. So for a sub n in general, where did this 5 come from? It came from our first term, so let's try the same thing. So let's grab 16. Where did the 10 come from? It came from your what you're multiplying by each time, right? So what are we multiplying by each time this time? -1/2. And then we needed this n minus 1. Let's start with this and see how we do. So if I plug in 1, the exponent becomes 0. Anything to the 0 is 1. 16 times 1 is 16. That works. If I plug in 2 to grab my second term, 2 minus 1 is 1. -1/2 to the 1 is -1/2. 16 times -1/2 is -8. I think we've got it. So all those sequences in the last screen were called geometric. And geometric sequences are when you multiply a common ratio r to find the next term, versus arithmetic, where we do what again? We add a common difference, d. So for geometric, we saw that each time we want to find the next term, we take the previous term times r. So let's see if we can't find a general formula for geometric sequences. So remember, for arithmetic, we started with the first term, and then we added our common difference n minus 1 times, okay? So let's do something similar for geometric. First term is going to be a sub 1. Second term will be the first term times my common ratio r. The third term is going to be the second term, which is a sub 1 times r, times another r, right? Which I can write this as a sub 1 times r squared. The fourth term will be my third term, times another r. So a sub 1 times r cubed. Do we see the pattern? Again, to find my fourth term, I want to multiply r 3 times. R times r times r is r cubed, right? If I want to find my third term, I want to multiply r times r by itself twice. If I want to find my second term, I need to multiply by r once. Okay, so if I want to find my 100th term, how many times do I need to multiply by r? 99 times, right, which would be r to the 99th power. So in general, to find the nth term, I'm going to start with my first term, and then I'm going to multiply by r n times, which would be r to n, minus 1 times. So it'd be r to the n minus 1. Make sure you've got this written down for geometric sequences. First pause on the screen, go ahead and copy example 4 for me, and then we'll do it together. All right, so we want to know the 7th term in this geometric sequence. Well, our general formula says to find the nth term, start with your first term, and then multiply by r n minus 1 times. Well, I've got a sub 1. What is a sub 1? A sub 1 is 3. Now I need to find r. Well, I know that 3 times r is 3.6, right? So to find r, you can always take one term divided by the previous term. And if you do 3.6 divided by 3, you get 1.2. And you can verify if you take 3.6 times 1.2, you're going to get 4.32. Take 4.32 times 1.2, you should get this 5.184. Okay, so now I have both pieces that I need. So the 7th term, so I'm going to let n be 7, will be my first term, 3, times my common ratio, 1.2, raised to the what power? Raised to the 6th power. And let's type that. All right, we should get 8.597952. And that is that. That's what I have for you all today. I will see you next time.